Okay, so let's do this question 3, question 2 now on alpha beta pruning, and I'll do alpha beta pruning and min max at the same time, so you'll see what's going on. So you start from 6, so basically you start from A to B, B to D, and then you find that D is a terminal node, D has value 6, which basically means B is less than or equal to 6, less than or equal to 6, and then you come down to B to E is 9, so you're taking minimum of 6 and 9, so will still be 6, so B is still less than or equal to 6. Now that there is no more children below B, B actually is equal to 6, and if B is equal to 6, then A's value, now A has a 6 at this point, and so its value is going to be greater than or equal to 6. So then I go down this side, and then you go to C, you go to C to F, you go to F to G. At this point G is 4, so that means F is greater than or equal to 4. Okay, and then now of course then basically you also look at the other child of F. This is 2, so max of 4 and 2 is still 4, and so this becomes equal to 4. The moment this becomes equal to 4, C becomes less than or equal to 4. The moment C is saying less than or equal to 4, A is saying greater than or equal to 6, I don't need to look at any more below this side. So this entire thing is cut off. Okay, and then at that point, of course, whatever is the current bound on A will be its value. So I'll just say A's value is 6, and then it's getting it by doing this particular move. That means A is getting that by getting move B. So backed up value 6 gets it with move B. Okay, so that's for question 2. And then question 2.2 is slightly more interesting. It's basically the same idea, but I'm just going to do it in terms of not numbers but actual variables x, y. So I again start from A, go to B, go to E. So and then I get to E, then this is x, and which basically means B is less than or equal to x, and then you see y at F. So then B will just be minimum of x and y, and it would be less than or equal to minimum of x and y first, but then you'll realize that there is no more children, so it is actually equal to minimum of x and y, which means A is going to say I'm going to get at least min of x, y as my backed up value. So A is greater than min of x and y. So now at this point it comes down, you go to C, go to G. As soon as you see G, that is Z, its value is Z, and so C's backed up value is less than or equal to Z. So for the rest, for you to be able to stop seeing the rest of this thing, it better be the case that C is saying less than or equal to Z, and this is saying greater than or equal to minimum of x and y. So you would stop doing that if in fact min of xy is greater than or equal to Z. That's basically if minimum of xy is greater than or equal to Z. This equal to is very important. It doesn't have to be greater than Z, it only has to be greater than or equal to Z, because in general you are allowed to, you may as well prune the search if in fact you are guaranteed that by looking at the rest of the tree you won't get anything better than what your current bound is. At that point, why bother? Okay, so it's really what you're going to be looking for is min of xy is greater than or equal to Z is the answer here.